Hey everybody, welcome to Chapter 2, Section 2, Solving Two Variable Systems of Equations with Elimination. The whole purpose of elimination is to combine your two equations together to eliminate or get rid of one of your variables. In order for that to happen, you need to follow these steps. You need to make sure both equations are in standard form, that's ax plus by equals c, something x plus something y equals your constant. If necessary, you'll need to multiply one or both equations by a number to cancel out a variable. So we'll get to that, we'll cross that bridge when we get there. Then we'll combine equations and solve for the variable that did not cancel. And then, so that's what elimination does. You add them together, a variable cancels, you're able to solve for the other variable, then you can plug that number back into an original equation to solve for the other variable. And then you're always able to check your solutions by plugging both your answers back into one or both of the equations to see if it works. So let's take a look at number one here. I have both equations already in standard form, something x plus something y equals your constant number c. And so the next thing I need to determine is if I add these two equations together now, is their variable ready to be eliminated? Or should I ask myself, or you should ask yourself, do I need to multiply one or both of these equations by a number to eliminate a variable? And the answer to that is no, you don't need to. It's ready to add together. Why is it ready to add together? Because x minus x makes nothing. So when you add together the rest of the problem, negative 3y plus 2y will equal negative 1y. And that'll equal 2 plus negative 3, that'll equal negative 1. And so if negative y equals negative 1, then positive y equals positive 1. Okay? And if that confuses you, think of it like this. Anytime there's a negative by a letter, that doesn't mean you're done. That doesn't mean, oh, this equation equals a negative. No, it means negative 1 times y. So you got to divide out that negative 1. And any negative 1 divided by negative 1 is 1. Anything divided by itself is 1. So I just like to think of it as flipping the signs. Hey, if negative y equals negative 1, then positive y equals positive 1. Take this y answer and plug it into either equation, the original equations. Okay? So if it helps, you can erase the stuff you've eliminated before. And then you can plug it into one of the original two. So it doesn't matter which one. I'll just choose... since this x is positive, I'll choose to plug it in to this one right here. Okay? So I'm going to write x minus 3y, but instead of the y, it will now equal, or I'll plug in the number 1. Okay? So 3 times 1 is just 3. So basically it says x minus 3 equals 2. And so what number minus 3 equals 2? Well, that's 5, but I'm a math teacher, I'll show my work. I can add 3 to the other side and get x equals 5. So now that we've gotten our x and y answer, you just need to rewrite it as an ordered pair. Write 5, comma 1. And that's your x, comma y answer. Okay? And that's all there was for number 1. For number 2, check to see if they're both in standard form. You have something x plus something y equals your constant, so you're good. Do you need to multiply one or both of your equations by a number to get them to eliminate? No, you don't, because you have a negative y here and a positive y there. So when I add the two equations together, those will cancel. So I'll have 7x equals 14. Okay, so 7 times what number equals 14? Or think about it like this, 14 divided by 7 is 2. So 7 times 2 equals 14. So I got my x answer. So go back to one of your original two equations. Again, if it helps to take that out, I will. But yeah, just take the 2 and plug it in for x. It doesn't matter which one you plug it into, so I just chose the top one. 4 times 2 minus y equals 5. So that's going to make 8 minus y equals 5. So 8 minus what number is 5? If you don't know, then you'll have to subtract 8 to the other side. And you get negative y equals negative 3. And so if you're saying to yourself, wait, 8 minus 3 is 5, not 8 minus negative 3, that's because you have it negative y equals. So it's what I said before. If negative y equals negative 3, then positive y equals positive 3. And then you could achieve the same thing by dividing by negative 1. That would get your negatives to cancel, and that would get you to equal positive 3. Okay? So just rewrite your final answer as an ordered pair, 2, 3, and then we can move on to the next one. But I haven't shown you the checking process. This is just for anybody who wants to check their work. Plug them back in, and it should equal what it's supposed to equal. So if I were to check my work, it would look like this. You just have to plug in 2 and 3 back into your original equations. So this would give me 8 minus 3, that does equal 5. This will give me 6 plus 3, that does equal 9. So that's how you know you did it right for sure, just plugging it back in. Okay, so moving on to number 3. Are both equations in standard form? No. The bottom one is x, y, constant. This goes y, and then there's an equal 7 minus x. So how do I get that top equation into standard form? All you really have to do is plus x to the other side. So plus x here, plus x there. So it's a little crowded. So I'm going to rewrite it here. X plus y equals 7. Okay? So am I ready to eliminate a variable by adding them together? No. Because if you added these together, you'd have 6x plus 3y equals 15. So you're not eliminating any variables. So what I need to do now is I need to multiply at least one of these equations by a number to get the variables to eliminate. So you can choose to eliminate the x's or the y's. It really does not matter. In the event where you need to multiply an equation by a number, it really doesn't matter. So I'm going to choose to eliminate the x's. So I'm going to multiply this by negative 5. The reason why I'm going to multiply by negative 5 is because negative 5 times x will give me negative 5x. And if I add that to positive 5x, it'll equal 0. But you can't just throw in a negative 5 to the x and then expect everything to be okay. The rules of algebra say what you do to one side, you have to do to the other. So that means I have to multiply negative 5 times everything on this side and everything on the other side of the equal sign in order for it to be justified. So I put the whole equation in parentheses, and I'll write negative 5x minus 5y equals negative 35. Okay, now I've scaled that whole equation up by a factor of negative 5. So what I'll do now is I'll rewrite this equation right here, and then I'll add the two together. So you see I have 5x plus 2y equals 8. I just rewrote that equation, this equation right here, so that they're stacked on top of one another. So that way when I add, it makes sense. Negative 5x plus 5x equals nothing, and then negative 5y plus 2y would equal negative 3y. And then negative 35 plus 8 would make negative 27. So how do you get rid of a number by a letter? You divide. Negative 3y means negative 3 times y, so the opposite would be to divide. They're married, multiplying together, so divorce, divide them apart. And you get y equals positive 9. So we got y equals 9. Plug it into any equation. This one or this one. Go back to the original. You could, if you plugged it into the 9 right here, it would also work. It doesn't really matter. So I'm just trying to keep things simple, and I'll just plug it into an original equation. So I'll do y equals 7 minus x. So instead of y, I'll write 9 equals 7 minus x. I'm looking at this top original equation, okay? So 7 minus what number is 9? It's going up, so you have to be minusing a negative number. So what am I going to do? I'm going to divide by negative 7. Now, divide. I'm going to subtract out 7. 9 minus 7 is positive 2. So if positive 2 equals negative x, then positive x equals negative 2. All right, so I'll say it again. Negative x equals positive 2, so positive x equals negative 2, the opposite signs. And then, if that confuses you, you can always get rid of a negative by a letter by dividing by negative 1, because it's understood it's negative 1x. All right, so 2 divided by negative 1 equals negative 2. So yeah, I have my x and my y answer now, so I just need to write the ordered pair. My ordered pair would be negative 2, comma, 9. Remember, all ordered pairs are x, comma, y. So now that number 3 is over, let's do the last example. So number 4, neither one is in standard form. You see the 6y needs to go on this side, the negative 5x needs to go over there. So don't just rewrite them on the other side. If it's going to the opposite side, it needs to be the opposite sign. Opposite side, opposite operation. So if it's a positive 6y on the right-hand side, then I need to subtract it, so it'll become a negative 6y on the left-hand side. And so it's just real crammed together, and I'll write it neater in a second. But that'll cancel out the 6y on the right. And then if it's negative 5x on the right, then I need to make it become positive 5x on the left. So I'll plus it over. Okay? So I'll rewrite my two equations in standard form now. So the top one, I put the minus 6y over. So that means I had a positive 7x minus 6y, okay, equals 9. And then the other one, it was plus 5x, a positive 5x, and it was a positive 2y. So that means I'll put a plus sign, and 2y equals 19. So now they're both in standard form, okay? But they're not ready to eliminate. If I added them together, the x's wouldn't cancel and the y's, nor would the y's cancel, okay? So now I need to determine which variable would be the easiest to cancel. So looking at the x's, there's nothing 7 and 5 go into. But looking at the y's, I know that 2 times 3 makes 6. And so if I have a negative 6 on top and a positive 6 on bottom, I'll be able to eliminate my y's. So that means I have to multiply the entire bottom equation by 3. So that'll give me 15x plus 6y equals, and 3 times 19 is 57. And so what I'll do now is I'll just bring this equation down here. I'll stack them on top of each other. So that way when I combine them, it's clear what I'm eliminating. All right, so I'm going to add together the 15x and the 7x to make 22x. And then the y's would cancel, and that'll equal 66. 57 plus 9 is 66. So 22 is married or multiplying to the x, so divorce divide them apart. 66 divided by 22 is 3. X equals 3. So take that 3 and plug it in to, one of the original equations. If you plugged it into one of these, you'd still get the same answer, but I try and keep things simple and just go back and plug it into the original. So I think the easier one for me to plug it into would be this bottom one, since it's almost in y equals form. So I wrote 2y equals negative 5x, but I plugged in that 3, so negative 5 times 3 plus 19. Now let's just do the math. This makes negative 15 plus 19, and then that makes negative 4. So I'll bring down the 2y. So if 2y equals negative 4, oh, it's positive 4, what am I saying? Negative 15 plus 19, 19 is bigger than 15, so it would be a positive number. So I'll divide by 2. 2y means 2 times y, so the opposite of that would be to divide, and y equals positive 2. So I have my final two answers, I guess I could say that. I'll rewrite it as an ordered pair, 3, 2 for x, y. So before I go, I want to show you another way you can check your work, and that's by graphing it. What I did was I used the Desmos app. You can use Desmos or GeoGebra, and you can type in the original equations. So in case you made a mistake along the way, just type in the originals and graph them, and it can show you the intersection of the two lines. And so you see here, I got 3, 2. So that's always a good way to check your work. You can always plug your back answers and check it in algebraically like I did in the second example, or you can graph it. But other than that, thank you for watching. Hit that like button and subscribe if you feel like it, and goodbye.